Okay, this question says simplify sine theta cot theta. I know cot is cos on sine, so it actually equals cos theta. Simplify this sec B, where they're acute angles, sine 90, notice I write it every time, sec B, sine 90 minus theta is actually equal to cos of the angle, and sec is 1 on cos. So the answer is simply 1. 3. Simplify. Because they're squares, I'm thinking cos squared, sine squared. Let's see what we've got here. I'm going to take sine squared out the front and simplify it to say it's sine squared plus, and I'm left with a cos squared over here. So it's actually root sine squared theta times 1, which is sine theta. 4. Prove that cot plus tan is that. Now when we prove, we have to take one side and show that it equals the other side. So I'm going to take the left hand side. You could take the right hand side, it doesn't matter. And I'm going to prove cot plus tan is cosec and sec. Well, I know cosec and sec are sines, so I'm thinking that if I swap the cot to be cos on sine and the tan to be sine on cos, what happens if I get a common denominator? My numerator becomes cos squared x and sine squared x on sine x cos x, which is cosec, or 1 on sine is cosec, and 1 on cos is sec. Right hand side, therefore true. Let's have a look at example 5. Again, I'm going to take the left hand side, because I'm not sure what I would do with this right hand side, but I know the left hand side, at least I can break this bottom up to be sine squared is 1 minus cos squared. So I've got 1 minus cos, it should have an x there, over 1 minus cos squared x. Well, isn't the numerator the difference of two squares? 1 minus cos x, 1 plus cos x. That goes, and I'm left with what I require, which equals right hand side, therefore true. The more you practice these, the better you'll get. They're like trial and error.